Welcome to Twin Civet AI and Machine Learning Lessons. I'm Blake.
And I'm Jude.
Today we're diving deep into something really quite ingenious in machine learning, semi-supervised learning. Just picture this for a sec. You got this vital AI project, right? But getting all the data labeled, it's a huge job, super costly, a real bottleneck.
Exactly. That's the problem.
Yeah.
SSL, semi-supervised learning, is really built to tackle. It's becoming a bit of a game changer out there.
We all know how standard supervised learning just eats up labeled data. It needs loads of it.
Right. And unsupervised learning, well, it works with unlabeled stuff, finding hidden patterns, but sometimes the results aren't quite as precise,
So what if you've got just a little bit of that good labeled data and then this massive ocean of unlabeled data lying around?
That's the sweet spot for SSL. It's this clever bridge, really. It takes your small, valuable set of labeled examples and smartly uses them alongside the huge amount of unlabeled info you already have.
Making things faster.
Faster, definitely more cost-effective, and often you don't even lose much accuracy. It's quite powerful.
And what's really cool here, I think, is how it uses that unlabeled data. It's not just background noise, is it?
Not at all. That unlabeled data often holds really critical clues about the underlying structure, the distribution of your data. We kind of rely on a few core ideas, these assumptions.
Okay, like what? Tell us about those.
Well, there's the smoothness assumption. It basically says, look, if two data points are really close together in the input space, they should probably have the same label. Makes sense, right?
Intuitively, yeah. If things look alike, they probably are alike, classification-wise.
Exactly. And this idea lets labels sort of ripple outwards, through the unlabeled points, connecting things.
I see. Okay, what else?
Then you've got the low density assumption. This one suggests that the best place to draw the line, the decision boundary between classes, is probably in the empty spaces, the scarce regions, not right through a dense cluster of points.
Like finding the path of least resistance through the data.
You got it. And finally, there's the manifold assumption. This recognizes that even data with tons of dimensions, high-dimensional data, often actually lives on simpler, sort of lower-dimensional shapes or surfaces within that space.
Like points scattered on a crumpled piece of paper inside a big room. The paper's still fundamentally 2D, even if it looks complex in 3D space.
Precisely that kind of idea.
Yeah.
And SSL assumes points lying on that same manifold, that same surface, should share a label, even if they seem far apart in the overall space. These assumptions, together, they make the unlabeled data incredibly informative.
That really paints a clearer picture. Okay, so bringing it down to earth, how does this actually, impact things? Where are we seeing SSL making a difference for you, the listener?
Oh, it's making waves in areas where getting labels is just tough or expensive. Think about fraud detection. Only a tiny, tiny fraction of transactions are ever confirmed as fraud.
Right, you don't have many examples to learn from.
Exactly, or speech recognition. Labeling hours and hours of audio by hand, it's incredibly labor-intensive. Companies like Meta, for example, they've seen huge improvements. They might train initially on a bit of human-labeled audio, and then use something called self-training on maybe hundreds of hours of unlabeled speech. And boom, the word error rates drop dramatically.
Self-training, how does that work mechanically?
Well, the basic idea is you train an initial model on the labeled data you do have. Then you use that sort of preliminary model to make predictions on all your unlabeled data.
So it guesses the labels for the rest.
It guesses, yeah. We call them pseudo-labels. They might not be perfect, a bit noisy perhaps, but you treat them as if they are labels, at least for a while.
Okay.
Then you retrain your model using both the original labeled data and these new pseudo-labeled ones. You can repeat this, iteratively refining the model. It learns more from the sheer volume of data, even if some labels are just educated guesses initially.
That's clever, using the model to bootstrap itself.
Right. And it's not just pseudo-labeling. There are also these really neat graph-based methods. You represent your data, like a network, nodes and connections, and you let the labels propagate or spread across the connections. Think about predicting maybe customer interests based on who they're connected to in a social network.
Yeah.
SSL is great for that kind of thing, too, like classifying web content on Google without needing every page manually tagged.
Okay, this sounds incredibly powerful, but it can't be perfect, right? There must be catches or situations where maybe it's not the best tool.
That's a really important point. SSL isn't a magic wand, not a silver bullet. Its success really hangs on the quality of that unlabeled data.
Ah, so garbage in, garbage out still apply?
Very much so. If your unlabeled data is super noisy, or if it doesn't actually represent the real patterns you're trying to learn, using it can sometimes even make your model worse than just using the small labeled set alone.
So when should you maybe hold off?
Well, look, if you're lucky enough to have tons of high-quality labeled data already, standard supervised learning might just be simpler and more reliable. Stick with what works, you know.
Makes sense. Don't overcomplicate if you don't need to.
Exactly. But SSL really comes into its own when those labels are scarce, they're expensive to get, and you have good reason to believe the underlying data structure has that smoothness. We talked about similar inputs likely having similar outputs.
Got it. So assuming it's a good fit, what are the best practices? How do you make it work well?
Careful groundwork is key. Meticulous data pre-processing, cleaning up that unlabeled data as much as possible. Then choosing the right SSL algorithm, there are quite a few variations, and definitely continuous monitoring of performance. You need to check if it's actually helping.
Right. Keep an eye on it.
And techniques like transfer learning can sometimes help initialize the model, and regularization is important to prevent overfitting, especially when you're dealing with potentially noisy pseudo-labels. It's about being smart and careful with this hybrid approach.
It's definitely clear that semi-supervised learning is, well, a really vital tool in the AI toolkit. It helps machines find these complex patterns even when we don't give them all the answers up front. It really makes you wonder, doesn't it? What other hidden structures are out there in all this data waiting for machines to uncover as we get better at letting them learn with, less direct supervision?
That's all for now, folks.